So as we have discussed in the previous videos that how to find out the shortest path between the any two nodes is given. We have discussed the two algorithm for that. The first one is dicussed algorithm. The order or time complexity for that algorithm is of order n square. And we have another algorithm we have learned, that is a flawed-Warsaw algorithm. The time complexity for flawed-Warsaw algorithm is of order n cube, big O n cube. So for the large spread graph, the Kruskal algorithm is more preferable to use. In this video lecture or in this lecture, online lecture, we are dealing with the how to calculate the minimum spanning tree from the given graph. Now, what does it mean of a minimum spanning tree? As we have discussed, the spanning subgraph means the vertex set will not be changed. And the spanning tree means it has to be a tree which includes all the vertices. And minimum spanning tree means we need to find out a tree in which we can travel all the vertices with minimum cost. That is known as a minimum spanning tree. Okay? And it summarizes the distance network of a locality, and the number of each edge represents the distance between the nodes and connected by the edge. So what is the objective of a minimum spanning tree problem? This is a minimum spanning tree problem. For example, in this, the given graph is there or a network is there. We need to calculate what is the minimum spanning tree in it. So it is to connect the node of the network by a set of edge in such that the total length of the edge is minimized. And in this process, constructing a minimum spanning tree, it should be taken care that there is no cycle in it. With the reference to telephone network, lying example that the objective is to connect the all nodes by set of edge such that the total length of the telephone cable to be laid is minimum. Okay, for example, you have to set up a telephone network, and what is the objective is the length of the cable should be minimized, has to be used. So that's why this finding the minimum spanning tree is very crucial and very important. We are going to discuss a two algorithm to do this in this today. The first one is a Prim's algorithm, and the second one is a Kruskal algorithm. These two algorithms we are going to discuss today, and the objective of both this is to find out the minimum spanning tree. So for that, we'll consider one graph G, which is a weighted graph. And what do you mean by weighted graph? As I already discussed that each edge E has assigned some real number, W of E. It's called the weight of the edge E. For example, here the weight of the edge 1 to 2 is 10, in that manner. If H is a subgraph of the weight graph and the weight of WH, I can say weight of H, is the sum of edges of this weighted graph, and I want that a spanning tree of that weighted graph, it's called the minimum spanning tree, if this weight is minimum. Okay, and that we are going to learn or with these two algorithms. So I will first talk about the Kruskal algorithm, and then we'll go for the Prim's algorithm. So let us write steps to obtain the minimum spanning tree using Kruskal's algorithm. So for that you need to have let G, which is a graph with the vertex set V and edge set E, be a weighted graph. So you need to have a weighted graph. Weighted, and also you need to have a connected, otherwise the spanning tree will not be possible. So it is weighted connected graph you require. Now what is the step number 1? The step number 1 is says that select an edge of G such that the weight of that edge is minimum. So first is we need to select an edge EI of G such that its weight W of EI is minimum. Given to you, you have to first, so for example in this previous graph, you have to find out an edge which has a minimum weight. So we know that this is the 3, which is a minimum. So the edge 5, 6 is minimum. So that is our edge. So that we have here. We have to do in the first step. Select an edge which is having the minimum weight. Now step number 2. In that case, that means you have to do the first one. If the edge or edges E1, E2 up to Ek have been chosen, then select an edge Ek plus 1 such that Ek plus 1 is not equal to Ei for all I running from 1 to K. B. The edges E1, E2 up to Ek plus 1 does not form a cycle or circuit. It should not form a cycle or circuit. You have to choose an edge Ek in such a manner. So for example, first we have selected this, the edge 5, 6 from this. Then you have to select the other edge. Okay, so that is the things. The other edges, even E2, if it is selected. If not selected, then you have to all the edges in the consideration you have to consider. So that when you choose another edge, it should not have any cycle with this edge. So that is the things we need to do. Now step number C in it. The weight W of Ek, weight of W of Ek plus 1 is as small as possible. So we have to choose a weight Ek plus 1 as small as possible, subject to condition the number 2 or the number D of the step 2 is follow. That means this has to be no cycle will be there. Okay. So that is small as possible subject to the condition number 2, number B of step 2 above. Now step number 3. Stop when all the vertices of G are in T. T is a tree, a spanning tree, which is required a spanning tree of G with n minus 1 edges. So whatever the number of vertices is there, that minus 1 is number of edges in the tree that we have already discussed. So these are the steps we need to follow. Let's have one example and try to see how this Kruskal algorithm is worked. So use Kruskal's algorithm to find the minimum spanning tree of the graph of this graph what I am plotting. So this is my vertex 1, 2, 3, 5, 4 is here, 5, 6. And there are weights also given to each edge. So this is 25, this will be 10, 45, 30, 20, 55, 15, 35, 40 and 50. So this is the graph. So as per this algorithm, what you have to first step, the first step tells you that you have to select an edge EI such that the weight will be the minimum out of this. So we have to select an edge which has a minimum weight. So that means the edge we have, it is this edge 1 to 2. The 10 is the weight which is a minimum one. So we'll do that. So I'm making one table here. The first one is a serial number. The next one is an age. Then we are putting the weight, whatever the weight is there. And then corresponding graph. What should be the corresponding graph you will have? Okay, so this is my table. So this is the first one, serial number is 1. What is the age we have taken? The age is 1 to 2. So the age is 1 to we have added. What was the weight? The weight is 10. And what is the corresponding graph? The graph is this. This is 1, this is 2. Okay. Now second. Serial number second. Now you have to select the another Another age which has, so as per the rule we need to go. Okay. Step number 1, select an age, and we have to repeat this process. So select an age. Now the previous one is not selected, and there is no cycle. That is a rule is there. So the next minimum age is 15 that we can see here. This is 15. Okay. So the age is 3 and 6. So we'll put them that age here. 3, 6. The weight is 15. The corresponding graph you will have 1 to 2 and 3 to 6 is the corresponding. Next, in the third number, we have to select an age next minimum to that. The next minimum is, we see it is 20, this age, and it will not form a cycle with these two ages which we have selected. So that's why here the age is came is 4, 6. What is the weight of that? It is 20, and the corresponding figure, that will be 1 to 2, 3 to 6 is already there. Another age is added to the 6, that is 4, 6. So this will be the 4, 6 you have. This is the corresponding figure. Next, the fourth number. That you have to take now next one. What will happen? What will be the next minimum weight? The next minimum weight is
25.
25.
4, 2.
So what is 25 is here. You have to choose a 25. And you have to check whether it is form a cycle or not. So we have taken this, and this one, and it will not form a cycle. Okay, so the 25 you can choose. The next one is the weight, age is 2 to 6. This was the age.
Sir, 2 to 4.
2 to 4. 2 to 4. 2 to 4. The weight is 25. Okay, and what is the corresponding figure you have? Here it is 1, 2. Then 3, 6 is selected, and 4 is also there. This was the previous figure, and now we have added 2 to 4. So this is the figure you have. Okay.
Sir?
Yes.
Sir, it is rounded na sir, ऊपर से जा रहा है ये तो.
So it's okay. It is an age.
Okay sir, it is on us na how to make.
Yeah, it is kind of isomorphic graph.
Okay sir.
Now the fifth step, the fifth one, that is the next weight, which is after this 25, is 30. Minimum one is 30. What will happen if I join 1, 4? If I join 1, 4, what will happen? It will form a cycle to 1 to 2, 2 to 4, and 1, 4. So it is not possible to take this age 30. We cannot able to pick up a 30. A next minimum one is a 35. If I join 3, 5, then nothing problem, because you can just see that 3 is already there. If I connect with 5, no problem with that. So the next age is 3, 5 you need to select. 35. and the corresponding age is this 1 to 2. This is 4, this is 6, this is 3, and 3 to 5. So this is covered all the vertex of the graph G. It will cover all the vertex of the graph G, and also it is a minimum one. So what will be the total weight? Total weight is equal to 10 plus 15 plus 20, 10 plus 15 plus 20 plus 25 plus 35, 25 plus 35. Okay, so you will have the answer is 105 unit, whatever the unit is there, which is the minimum weight of a spanning tree, is given in this figure. All right. So, is there? I have to do another example with the same, or you will do it. So, I can give you as an exercise that you can calculate the minimum spanning tree for this graph using the Kruskal algorithm. Is it fine? You are able to do that?
Yes, sir. Sure.
Yes, sir.
Yeah. Thanks. Okay, so we'll move forward with another algorithm. That is Prim's algorithm. Prim's algorithm. The objective of Prim's algorithm is again to find out a minimum spanning tree from the graph G. So let us write the step for this Prim's algorithm. Let T be a tree in a connected graph G. Represented by two sets. The set of vertices of T and set of edges in T. So this is the T is a subgraph of G. I can say it is a tree is a subgraph of this graph G, connected graph G. Now in the step 1, what you have to do? Step 1. Start with, so in the Kruskal algorithm, what we have started with one edge. Here we are starting with one vertex. Start with vertex V0, say in G. No edges such that T of, now T is a tree which we are looking for, which contains one vertex set V0 and no edges is there. Fine. Step number 2. Find an edge E1 at V0, V1 in G such that the end vertex V0 is in T and its weight should be minimum. Weight is minimum That means WE1 is minimum. Adjoin V1 and E1 to T. That means you have T is equal to, now vertex side has 2, V0, V1, and edge side is E1. Step number 3. Choose a vertex next edge. Now EIJ, that is VI, VJ, in such a way that the end vertex VI is in T and the end vertex VJ is not in T. And obviously the weight of EIJ is as small as possible. Once you choose that, adjoin them. Adjoin VI and EIJ to T. Step number 4. Repeat step 3 until T contains all the vertices of G. Then you will have the set T will give a minimum spanning tree. Of the graph G. Okay. So let us consider the graph and let us try to find out the minimum spanning tree in that graph using Prim's algorithm. So let's have this as a graph. A, B, C, D, E, F, and G. So this is the graph you have. And we have given a weight which will be 20, 12, 12, 10, 6, 4, 6, 6, 4, 8, 40. This is the graph. Now, as per the Prim's algorithm, we are starting with the one edge. Sorry, in Prim's algorithm, we are starting with one vertex. Instead of edge, we have here, we can write a tree whatever the tree we have. Fine. So in that we are starting with the first, the question or the Prim's algorithm. We are starting with any vertex here. So in particular, I'm just starting with A. So my P is consisting only one vertex A, and there is no edge is there. So here corresponding graph is just consider one A, that is one vertex. In second, now you have to find out a minimum weight, okay, minimum weight of A which adjacent to A. So what is the minimum weight is adjacent to A? So there are three weights is there, the 12, 14, 20. Out of this three, the 12 is the minimum one. So we have to pick a 12 from here. So that means the vertex which we have to add is AB. B is vertex added and the edge AB is added into this tree. So this T is vertex set is A, B, and the edge set, it is the edge AB. And the corresponding graph you will have, this is A and this will be B, is this. This is step number 2. Now third one. Now the minimum weight adjacent to B, okay, adjacent to B, minimum weight you have to find out. So there are 12 is already pick up. You have to pick now the other three, that is 6, 10, 12. The minimum one is a 6. So you have 6 is minimum. So you have to add an vertex E as well as edge BE into the tree. So now P will be having 3 vertices A, B and E, and edges will be AB and BE. And the corresponding graph you have, this is A, this one is B, and you have here E in the fourth one. Fourth. What you will have? E now. Now at E, from E, you have to pick up a minimum weight which adjacent to E. So there are certain weights are there. The first one is 14, the 8, 6. These are the 3 edges which are incident to, except this BE edge. So the 6th one is a minimum one. So that you can pick. But what will happen if, so this is the edge F, the vertex is F is here. So that is EF is added to this, the tree. Previously it was A, then it is B, then we have added E. Now we are adding F. And what are the edges? That is AB, BE E, F. These three edges are there. And the corresponding graph you will have, it is A here, then it is B. You have E, and then E connect to F. Fifth, E. Now E to F we have traveled. Now you have to find out the edge which are incident to F, which has minimum weight. So there are two edges which has incident to F. The first one is FG, another one is FD. But FG is minimum one, 4. So that we can add here. So T is nothing but now A, B, E, F, and then what was that? G. Yeah, G. So it is F and then it is G. And edges which will be AB, BE, EF, FG. And the corresponding graph you will have, this is your A, this will be B, this is E, this is F, and the next one is G, is added into that. Now in the sixth step, in the sixth one, we are at G now. So you have to look at in the graph. From G, only one incident is there, that is G to A. But what will happen if you join G to A? We join G to A, then it will become a cycle. So we cannot join this G to A. Okay. Now you have given a freedom now. You are able to choose an edge which are not be chosen and which has minimum weight. This 20 cannot be chosen here, because if we can choose this 20, then it will form a cycle. So there are edges which are not have been chosen. So the 20 is not chosen, 14, this one, 8 is also not chosen, 6, 4, 10, 12. This many edges have not taken in our tree. Out of this, the fourth one, this CD edge have weight 4. So that's why we can pick CD. Okay. So you can pick CD, that is your edge you can put into this. So you are now graph T or tree, we will be A, B, C, D, G, sorry, F, G, and then it is C. C is also added into that. So it is A, B, C, D, E, F, G. What are the edges? AB, then it is BE, then it is EF, FG, FD, and the last one we have added, it is DE. So your graph, corresponding graph will be this one. A is here, B, A to B, then B to E, then we have add F, then we have added G, then F, to G, F to G, and then we are adding what I did, CD. We are adding CD into this. So there is a problem happening. We have chosen A, B, C, D. C and D, both of them are not here. Okay, so we cannot pick that vertex. That vertex is cannot be picked up. Sorry, H. This one. So incident, the minimum weight is 4, that we can see. In the row of D, that means here, next minimum is 4, but the corresponding F is already present. So either you can pick which incident with F. So the pickup things is 6, not 4, because here in this algorithm we are starting. So if I connect with G to A, then we'll form a cycle. So we now the next previous one was F, which we have selected. So that means we should not take this CD both here. We have to take this H, that is FD, which is the previous to the G. So we have selected here with the sixth one, that is FD. So it is FD is all, sorry, F is already there, FD we have to take. So we are selecting this one, FD. And it is been this FD. Okay, this is there. Now the seventh step. So in the seventh one, your T. Now from D, we are at D now. We have to find out the vertex which is minimum age with the D in accident, that is 10 and 4. So 4 is the minimum one. We pick that. That's why it is now A, B, C, D, E, F, G, and it will cover all the edges. What are, sorry, all the vertices? What are the edges? AB, BE, EF, EG, FD, and DC. So you will have A to B to E, F to G to D, and then from D to C. And this forms our, it will cover all the vertices of the graph tree, and that is your corresponding tree, minimum spanning tree. Let me write the weight which are given into the graph. So it was 12 and 6. So it is 12. This is 6. E to F is also 6. F to G is 4. F to D is also 6, and D to C is 4. So you can sum them. So the total weight will be 12 plus 6 plus 6 plus 4 plus 6 plus 4. 38 unit, which is a minimum spanning tree appear into that problem. Okay. Let me give you one exercise to do it yourself. Obviously, you can work out with the previous example also. That means which we have did the Kruskal algorithm. That also you can do it. This is 1, 2, 3, 4, 5. And 6. The question is to calculate the minimum spanning tree from this graph. The weight it's given 2, 11, 7, 8, 4, 1, 9 and 6. Okay, I hope that you guys can able to solve this example by yourself.